Thank you for coming back today at our channel, The Physics Mindset. And today's topic is about electrical energy. This is today's topic. A lot of people ask, what is energy? These are electrical terms we use in electrical engineering. Electrical energy, resistance, power, voltage, current. Now, without knowing any term in electrical, it will be hard for you to understand it. And that is the reason why we are here, to give you the basic knowledge and the terms to use when you're dealing in electrical engineering. Okay, let's jump into electrical energy. What is electrical energy? Let us see the definition of electrical energy. This is the amount of electrical work done. Or, remember, listen very well. This is the amount. Listen, some big terms we need to use. The amount of electrical work done. Or, it is electrical power consumed. Electrical power consumed. This is another term. Electrical power consumed over a period of time. Power is consumed per second. In fact, in energy, we always measure power in seconds, meaning every second power moves, power goes. Okay? Unless when you don't have power, that is when the meter or the consuming meter or the counting bill meter will stop counting. But once you have power and you have gadgets which are consuming, you see the word, which are consuming energy, the billing meter will count amount. It is the amount of electrical work done. Electrical work done is, let us say, a TV. Once a TV is operating, a TV is, that is electrical. Electrical is being worked up. Work done. Electrical work done. The amount. Now, what are the bills? What are the units going? Amount of electrical going to show the TV or to light the TV. For example, also, let's see our lights inside the houses. Once you switch on your switch, this is the light bulb, this is our switch, this is our battery. Okay, now once you switch, this is switch, this is the bulb, this is the power voltage. Now once you switch your switch on, the electrical power, the electrical energy will be used in the bulb. We are talking about electrical energy. Okay, and once the bulb starts lighting, that means it is the electrical power is being used to give light. That is the work done. And this is the electrical energy, the electrical work done. Or electrical power consumed over a period of time. Or let us say, when power is being consumed over a period of time, that is energy. When you switch on your switch, the bulb will consume power over a given period of time. Every second, this light, remember, time doesn't stop. Unless when yours or when your watch, the battery has gone down. But time continues moving every day, every second, every minute. Okay? And every second, this bulb will be giving light. Once the battery is on or the voltage is there. And that is when the more the bulb lights, the more voltage will be consumed. And that is energy. It is electrical power consumed over a period of time. Now, when power is being, how does this energy, what is this energy? Remember I told you, energy is a wide thing. Energy is kind of electric. Even electricity has some types of energy. There is a lot of types of energy. Okay, there is electrical energy. There is a lot of energy. Now, if electrical power consumed over a period of time is the amount of electrical work done, or is the electrical energy, how does this bulb consume our energy? Okay, now this is the logic behind. This bulb converts electrical energy, the work done, converts electrical energy into light energy. That is one of the type of converting the amount of electrical work done, or the electrical consumption, power consumption used over a period of time. Converting this electrical. Once there is no bulb, electrical will move freely. The voltage will not be used. And our energy will be at zero energy. Okay? Now, once you put a bulb and you switch on, our power will be consumed. Okay? Now, the amount of power being used is energy. That's why we have its formula. This is the formula to be used when you're calculating energy. Power over time. Energy depends on power and time. Remember, we saw power, that it is the wattage of the electrical or electronic gadget. The rate at which electricity is being used, that is power. Now, what is the time it takes to consume that power? That is energy now. Power times the time taken for the electrical, let's say a TV, an electrical gadget, to consume electricity, and the time it takes. That is energy. Okay? Always energy is measured. Energy is always measured in joules or kilowatt hours. You know, our electricity companies in any country you are, around the country, Uganda, Kenya, Zimbabwe, Nigeria, America, Canada, South Africa, Zambia, Ghana, you have electrical company which bills you every month. Okay? That is the government company or a private company. Okay? Now, every month, every home premises pays electrical bills. Every month. The only option you can use to stop paying those bills is using solar system. Nothing else. Another option, you will be blacked out. Okay? Using solar system is one of the best solutions to solve a problem of paying bills every month. But once you don't have solar system, and we have all the videos concerning solar systems, go back and watch these videos and you will know the useful part of a solar system to prevent yourself from paying these electrical bills every month. But once you're paying electrical bills, here we are, and we are seeing the topic about energy. Okay? And these electrical bills are measured in kilowatt hours. Okay? Or joules. These engineers, to calculate the bills which they must give you, they calculate them in kilowatt hours. And we are going to see how they calculate this energy which you use, this power which you use, and the time taken for them to give you that electrical bill. I'm going to show you how they calculate the bills. Okay? Now, if they use joules or kilowatt hours, and the formula of electrical energy is energy equals power times the time taken. I was here explaining that once electrical energy is being converted into another form of energy, That means power is going to consume electricity. Everything which changes, which converts electrical energy, all electrical appliances always convert or change electrical energy into another form of energy. Check this. I was explaining about the bulb. The bulb converts or changes electrical energy into light energy or heat energy. But we are always interested in light, though heat is also there, which we don't use, meaning a lot of power, a lot of energy is being used in that heat which we don't use. Okay, we only need light. Okay, another type of converting electrical energy, and this is once this electricity is being converted into another energy, it is what we are talking about, the electrical work done. Okay, and anything which converts electrical energy, it has power, it has watts with it. Let us say this bulb has 25 watts. Now the rate at which electrical energy is converted is 25 watts, and the more wattage, the more watts this electrical appliance or electronic appliance is having, it shows that is the more energy is being converted, or the more electricity is going to move. The rate. Check this. A lot of people, students, electricians, confuse power and energy. These are two things. Power and energy are two things. Okay? How? Power is the rate, the speed, or the flow of electrons. Take it to be the rate. The rate is like the speed. As I've told you, if a TV is this bulb it has watts of 100 watts, the rate of consuming electricity is high because it is a 100 watt bulb. Check a motor. If a motor has 1000 watts, its rate of consuming power is high, meaning the rate of consuming this electricity energy is high. I'm giving the difference between power and energy. Okay? Now, power is the rate or the speed to consume electricity. That's why I told you, when you buy things with less wattage, the amount, the speed of consuming your electricity will be low. That is power. Understand power. Now, let's come to energy. Energy is the amount, this word, the amount of electrical work done. Electrical work done is power. These are two things. Power is the work done. Work done is the rate at which at which electricity is being consumed. Now, energy is the amount, how many power has consumed the electricity. The amount of power consumed over a period of time. You see our definition. Electrical energy is the electrical power consumed over a given period of time, and is the amount. Energy is the amount. That's why our electric companies, they bill us according to the energy, kilowatt hours, or in joules. That is energy. They calculate us in energy, not in power, not in watts. For the watts, it's you who must measure, who must be in conscious that how many watts am I using in my house. Don't buy things which consume a lot of power. Consuming a lot of power is the wattage. buying things which have high wattage and you put it into your house. It is your control. Now, for an electric company from the government in your country you are, any country you are, for it will change this power and it multiply it with the time your power is consumed. That's why we have with the formula of power times the time taken, calculating for electrical energy. Okay, let me hope you have seen some difference, that power is the rate of consuming your electricity. That's why things are measured in wattage. The higher the wattage, the higher electricity is being consumed. The lower the wattage, the lower electricity will be consumed. Now, comes here. How many, the amount? This is the rate, this is the amount of electricity consumed. The rate at which the power has been consumed over a given period of time, that is energy. Power, the rate of consuming electricity. If it is low or high, there are two things. Either low power or low wattage or high wattage. It is either you consume your electricity very fast or you consume your electricity very low. Very low means low watts. Very high means high watts. That's why when you're buying your electronic gadgets, your electro gadgets, always consider the watts of that machine. Either a cooker, either a washing machine, either a TV, a kettle. Please always consider the watts. The more you see high wattage, that is power, just know you will pay a lot of energy. A lot of energy will be consumed. Here, if we're talking about the energy, a lot of energy, the amount of energy will be high and you will pay high bill, electrical bills. Okay? Let's come back. Let's come back to our electrical energy. Okay? Now, I was here converting this electricity. Energy is a converting electrical energy into another form of energy. Now, once you put here your let me give you one of the, I was telling you that all electrical appliances converts electrical energy into another form of energy. And I was explaining that light converts electrical energy into light energy and heat energy. Okay? If you are trying to use your fan in the house, a fan has a motor inside it, and a motor converts electrical energy into mechanical, and that is the fan. A fan converts electrical energy into mechanical. Where mechanical is when you see that those three turbines which blow and give you fresh air. That is mechanical, but they have converted electrical into mechanical. Let's say a radio is an electrical gadget or electronic gadget because it is electrical and electronic. It uses electrical to give you in its electronic board. Now, a radio converts electrical energy into sound energy. Those are forms of energy. Okay? And a heater where you cook your food converts electrical energy into heat energy. You see how energy is being converted or changed. And these electrical appliances which I have mentioned, they have wattage. And the moment they convert anything converting electricity into another form of energy, it has watts, it has power in it. And the power in it, the amount, how long does this, let's say, how long does our fan blow here in our houses? Oh, how long does our bulb how long does it give us light? How long, the time taken. That is how long. Okay? Now, for energy, to calculate energy, we get the power of that bulb times how long. That is the time taken. Meaning, we need to know the power of the bulb, if it is 20 watts, times the time it lights. If it is 6 hours, then 20 times 6, that is 120 joules. That is energy. Okay? The formula is here. Power times time. We are going to see the types, the formulas of electrical energy, which you can use as an electrical student or electricians, or you want to design something, or you want to know the electric bills. We are going also to calculate everything, and I show you how these companies give you the bills. Okay? Now, I wanted to show you something small here about to understand this topic, electrical energy. I wanted to talk about the water principle. You know, I love explaining this electricity, because always, every day, people use water, and everyone knows water. A lot of people know about water, that water is here, water is everywhere. But electricity, few people take notice in its mechanism, in its principles. That's why I relate water principle with electrical principle, so that I soften the understanding, so that you get something. Okay? Now, check the principle I've brought. Water principle, we say, think that it is water. Okay? But in actual sense, we are in electrical. Okay? Don't confuse those things. Now, when water is flowing, water flows in the... Sorry. Let me give you a small illustration. Now it is more of technical. This is the pipe. Okay? This is the water pipe. This is our water. Connected on the pipe. Okay? This is water. Now, water flows in the pipe, right? That is okay. That is right, that water flows in the pipe. And water has pressure which pushes it in the pipe. Okay? Now, take that knowledge of water, this pipe to be the cable, our copper cable. Okay? Now, this pressure to be our voltage. And this water, let me show you something. The water flow, this water which flows, is the electric current. I want you guys to understand these things. Electric current, you understand the voltage, you understand power, you understand energy. Because you are soon starting the generation, I want you guys to be flexible in electrical. And I will show you everything, how to connect everything in electrical. Okay, so don't worry. Water flow is equals to electric current. Now, take that when water is flowing through a pipe, now change it into electrical, that this pipe is the cable. When you're wiring your installation, the cable current passes through the cable. Okay? Now, when the current is passing through the cable, the water flow is the current flow. Okay? Is the electric current, that is the water flow. Now, it depends how the amount of water flowing in the pipe. Also, it depends on the pressure which they put on the source. When these water engineers put a lot of pressure at the source to push, there are some water which have high pressure. Okay? Now, in electrical, we say the water pressure, that water pressure which pushes water, if the pressure is high, water will move very fast. And yet now in electrical, we said this water is the current moving in the cable. Now, when the water, what is the pressure? Let us see that the water pressure is the voltage. Okay? The water pressure is the voltage, meaning this is the cable, this is the current flowing in the cable. Now, the voltage at the source, if we have high voltage, let us say 240 or 400 volts, that is high voltage. Voltage is the pressure pushing current. Let us say we have current of 10 amps. Now, this is the current of 10 amps. The speed at which the current of 10 amps will move in this cable, it depends on the pressure. It is like water. When you have the high pressure at the source, a lot of water will move very fast. It can even push a human being. Okay? That pressure, you know that pressure. Now, it depends also on our pressure, which is the voltage. The voltage is the one which push the current to flow in a cable. Okay? And this is, the water pressure is the voltage. And see this. Always, it moves. Remember, always time is moving. Every second, every minute, time is moving. The time of flow, the time of this flow of water, it flows to where it is going. It may start at, let's say, at 7 a.m. But the moment it reaches another village, it will reach at 8 p.m. Okay? Now, it means there is some time taken. Now, the time of the flow of water, also as in electrical, we say it is the operating time. The time current is going to move from the source. Oh, let us say now this is our transformer. It has 400 volts, 10 amperes. The transformer will push, the 400 volts will push the 10 amperes. The 10 amperes will move through the conductors from one village to another by the help of a voltage. Once the voltage is limited, once the voltage is 240 volts, the one we use in our houses, it will not move too long distance. You see that's why we have what we call low voltage and high voltage. And now you can see where we use high voltages to transfer power from one place to another. But the moment it is moving, time is taking. And we come back to our electrical energy. The moment power is moving, time being taken, that is energy. I know it confuses a bit, but if you repeat the video, you will understand. If you watch the video once and you go, you will understand a bit, but another time when you repeat the video and you watch it the next time, the second time, the third time, you will understand a lot of things in electrical. Now, the pressure is the voltage, the flow of water is the flow of current, the amount of time taken for water to flow is the operating time. And this is the time we mean, okay? And we say, I have given here that the longer the electricity flow, the longer the current flow, okay? The longer, if the time takes so long for current to flow, the more energy is being used. That is the logic behind. The more your light lights up, the more energy is being used. And this energy, which are on our energy meter, it will continue counting. Energy meter, this is our meter. The meter will continue counting, and once the electrician or an engineer from electric company which bills you every month will come, he will just read the units which are on the meter and he converts it into kilowatt hours, okay, or joules, and he will give you your amount which you need to pay, because the more flow of current in a cable, unless when you have switched off, the flow of current will stop. But the moment you switch on, and every electrical gadget has a wattage, even 1 watt consumes energy. So every electrical gadget which is measured in wattage, that is power, times the time it takes. If your bulb lights for the whole day, it determines the amount of money. You see, the amount of money you pay, the amount of electrical work done. Electrical work done is giving us light, heat, and that the amount of that light it takes, it will be the amount of the bill you will pay. Power times the time taken, you find the electrical energy. Though it has some formulas which I'm going to show you so that you will be with them. Any question, if you're a student, any question which comes, which is within those formulas I'm going to give you, it is good to go for you to bang them, okay? Now, let us try to see the formulas, electrical formulas you can use in your day-to-day life solving electrical energy problems, okay? If you're a student and you're an electrician, technician, there are time which is going to come when you apply the formulas if you want to solve something concerning electrical energy. Any question which comes with electrical energy. Simply, we have the most important formula when dealing in electrical energy, which is, let's say, the electrical energy formulas of electrical energy, okay? Now, most important formula is finding E is equals to power times time, where E is the electrical energy, P is the power, T is the time. Time is measured in seconds, power is measured in watts, and electrical energy is measured in joules, okay? Now, this is the most important formula we need to use when you are dealing with electrical energies. E, which is represent electrical energy, is equals to power times time. The power to convert this electrical energy into another form of energy, and the time taken for this electrical energy to be transferred from one form of energy, from electrical to another form of energy. The forms of energy I told you, there are very many, and it depends on which electrical gadget or electronic gadget you're using. Either it converts into heat, either light energy, either from electrical to heat, electrical to light, electrical to motion energy, electrical to mechanical energy, electrical to sound energy, electrical. There are very many forms of energy. But after getting the power, we have the time it takes to transfer that form of energy, okay? There are another formula which you can use to solve electrical energy. We have this formula. There is this formula. Power is equals to voltage times current. This is one of the formula of power. Okay, power is equals to voltage times current. Okay, now convert this into electrical energy formula. Since if E is equals to power times time, but power is voltage times current, meaning electrical energy will be voltage times current times T. This is another formula. Therefore, this is also a formula you can use to calculate for electrical energy. Since P, power, is voltage times current, then you put this voltage times current here times the time taken, and you calculate for electrical energy, whereby this V will stand for voltage measured in volts, I will stand for current measured in amperes, then T will be the time taken measured in seconds. This is another formula we can use to calculate for electrical energy. There is another formula which you can use to calculate electrical energy. Check another formula. If power, okay, now these formulas help us to solve the electrical energy problems. When there is power or when there is voltage, current, then you multiply with time, also when there is time. Now, if power, always these formulas derive them from the formula of power, because we have power in it, okay? And yet, power has formula to drive before you drive for electrical energy, because we use this power, electrical energy, to find the formula of this, like for example like this one, power to consume the rate at which we convert that electrical energy. It has a formula to convert that electrical energy into another form of energy. Now, a power, one of the formula for power is voltage times current. Another formula for power is voltage squared over resistance. Now, if you calculate this, it depends on where is applied. Where are we going to calculate the electrical energy? Okay. Now, if there is voltage and we are dealing with resistance, use this formula to calculate for energy, whereby if power is voltage squared over resistance, since electrical energy is equals to power times time, then our electrical energy, we shall bring this formula, we put it where power is our electrical energy is voltage, to represent this power, voltage squared over resistance, this is the power, times time. This is how you calculate for electrical energy when you're dealing with voltage and resistance. From the power, this is another formula. We have formula 1, formula 2, then we have another formula which also solve the electrical power. Then you can see, and you can also solve electrical energy, which formula is, once power is equals to current squared, this was current squared times resistance. We have also this formula, current squared times resistance. Now, since power is current squared times resistance, then we transfer this P. Since P power times time, that is the electrical energy. Then our formula, we transfer this P to be current squared times resistance. Current squared times resistance times time. You see, energy, we always multiply that time. We need this time. Time. The mother formula is power times time. Now it depends on which electrical energy are you going to transfer. Is it light? Is it heat? Is it mechanical? Okay? You will see, according to these formulas, you'll have one you'll pick to use to solve your problems. We are going to solve some of the problem, and we see. Okay? And this is the formula. We have the mother formula. Electrical energy equals power times time. Formula 1. Formula 2, we have electrical energy equals voltage times current times time. Formula 3, we have electrical energy is equals to voltage squared times time divided by resistance, or voltage squared divided by resistance times time. Formula 4, we have electrical energy is equals to current squared times resistance times time. Okay? Whereby this R will represent resistance. Resistance. Measured in ohms. Okay? We have the current, we have the voltage, we have the time, we have the resistance. And using this, we can calculate any question in electrical energy. Students, master these formulas. Write them down, please. The mother formula, write it down. Then come slowly, check the question they have given you and solve slowly. Let us solve one of the questions. Let me give you a sample question to solve electrical energy. Let me give you a question and we solve it together. Okay, now, before we go to look at a question which we can solve in electrical energy, let me first show you the electrical units. Okay, you need to first know the electrical units. These electrical companies, they use a unit which we need to understand today. A unit in the electrical companies, they bill us in kilowatt hours. Okay, and the units in electrical energy are always in joules or kilowatt hours. Okay, because the SI unit for electrical energy is in joules. Okay, which is J. Okay, now all companies, in fact all companies measure in kilowatt hour, whereby in the units we have 1 kilowatt. This is 1 kilowatt. 1 kilowatt is the same as 1000 watts. Okay, this is one of the units you can use when you're dealing in electrical energy. Now, remember, these companies use kilowatt hours. Now, yet we said hours, we convert it into seconds. Let's convert. If we have 1 kilowatt hour, 1 kilowatt hours will be equals to, we first convert will be equals to 1 kilowatt hour, right? Or 1000 1000 watt hour. Now we need to convert this into seconds. To convert, let's try to convert. To convert hours into seconds. Okay, in 1 hour we have 60. In one hour we have 60 minutes, and in a minute we have 60 seconds, which will give us 3,600 seconds. These are now seconds. Okay, now if we have got the 3,600 seconds. Okay, now we are changing this into a kilowatt hour, but in seconds. We shall say 1 kilowatt hour is equals to, we multiply this 1000 kilo times the seconds in hours, the hours in seconds, and yet we have got 3,600 seconds. We do like this. This is how electrical companies come in to bill you. Now, what is this? This is a kilowatt hour, whereby we shall get 3,600,000. 1 2 3 1 2 3. This is in million. 3,600,000 watts. Okay, watt hour. In fact, this is watt hour, but we can change it into kilowatt hour, whereby this one you can either write it 3.6 mega. This is million is mega watt hour, you see. Or you can write it if you're going to change it in joules, 3.6 times 10 power 6. 6 means a million joules. You see, most of the standard figure, 3.6 times 10 power 6 joules. If you write it in megawatt, 3.6 megawatt hour. Okay, if you want it in watts, 3,600,000 watts. Okay, now, and this will help us to do the calculation, and this is how you convert your hour into seconds. Converting hour into seconds. Okay, now let us do a simple formula, a simple calculation, how these electrical bills, these electrical companies bill us. Okay, let me give you something small to show how these companies bill our people. Even me myself, if I have a house and I want electricity, meaning these companies are going to provide with their distribution of the electricity, and every month they put their meter to count me. Whatever I use inside my house, they will bill it. Even charging a phone, you will pay for it. I told you the only solution is to use solar system. That is the only way to run away from electrical bills. But without using solar system, either some people can use solar system with electrical system, and you divide some gadgets to use solar system then electrical. There you will have less electrical bill at the end of the month. But once you depend on electricity only, electrical bill will come, bro, when it is a bit high. Okay, let us try to see that simple question or simple way of how electrical companies try to calculate our electrical bills. Let me remove this. Hope you're getting some notes how we convert. Okay, this time round I've come up with a simple question so that we can understand well how to calculate electrical energy. Okay, a heater has a power rating of 1000 watts. A heater. Take this heater to be the coil we use in our house. Okay, it has a power rating of 1000 watts. It operates for 3 hours. Calculate the electrical energy used. Such a question, check how you can tackle it. You can write data. A heater has a power rating of 3 watts. We have power which is 1000 watts. And it operates, the operating time when you're cooking your food, either beans, okay, or meat, you cook for 3 hours. It operates for 3 hours. If you're cooking your meat for 3 hours, meaning we have time. Time, which is 3 hours. Okay, now they are telling us calculate the electrical energy used. You see, electrical energy used. Even you yourself, you can calculate the energy you're using with your cooker or a heater. Okay, excuse. Now our formula can be, let's use our formula of electrical energy, which is electrical energy is equals to power times time. And we have power and we have time. Okay, I told you one of the confusing things why students are failing such a simple question like this. Electrical students never calculate the hours which they have given you and leave it like 3, and you multiply your power times 3, you will fail the question. Always this time you need to convert the time into seconds. Always use seconds. How many seconds are in 1 minute? And how many minutes are in 1 second? Or 1 hour? In 1 hour, how many minutes we have? And in 1 minute, how many seconds we have? That is what we need to convert. It is always making students to fail such a question, such a simple question. Let us first convert. Since we have the power, which is 1000, that is okay. Now, convert this time into seconds, the 3 hours into seconds. How? Let's convert. Let me write here, convert. We convert the time. 3 hours, to convert it into seconds, we say in 1 hour, how many minutes we have? 60 minutes. And in 1 minute, how many seconds we have? 60 seconds. Meaning, we shall be having here, this is 3,600. Now we multiply by the 3 hours. Okay, let us multiply by the 3 hours. This is 0, 0, 3 times 6, that is 8, 18, 8. You carry 1, 3 times 9, 3 times 3, that is 9, plus 1, that is 10. We have our 1, 2, 3, 10,800 seconds. This is our seconds. You see how we are converted our seconds? 60 times 60 times the hours they have given you. You get your 10,800 seconds. Meaning, now you bring back your formula. E equals P times time. Power, they have said it is 1000 watts times the time in seconds. We get this time in seconds, 10,800 seconds. Okay, what is our electrical energy? Therefore, our electrical energy will be 0.80000. 1 2 3 1 2 3. It will be 10,800,000. 10,800,000. This is in joules. We said electrical energy is measured in joules. Now you can change this into a mega, because it is million, a megajoules. Convert this by million, you will get 10.8 megajoules. And this is the energy consumed. As simple as this. Always students or electricians forget this converting this time into seconds. But the moment you master this, it will simplify your work. Convert this time into seconds. 3,600 times the time given to you, then that is, you have changed that time. We changed this time into seconds and we got this. Okay, then come back to the formula, go back and solve everything, then you'll have your energy. The energy used is 10.8 million joules, that's the energy which is used by the heater that is power rated at 1000 watts. Okay, now if you get the energy used, let me give you a simple question. How these electrical companies try to give us the electrical bill, and you'll see how you can do it. Nevertheless, you can even start an electrical company which bills people. Okay, if you understand the electrical energy, then you will be able to calculate for people the bills which they use. Okay, now let us have some small question which shows us how these companies give us electrical bills. Okay, now we have some simple question which are going to solve to know how these electrical bills are calculated. Since we know how to calculate in kilowatt hour, now once you finish calculating in kilowatt hours, then the first thing you need to know is how much per unit. What is the unit? What is the unit cost per unit cost? In your country, whichever country you are, United States, America, that is America, Canada, UK, in African countries, Nigeria, Uganda, Kenya, Tanzania, Rwanda, Zimbabwe, South Africa, Gambia, Sierra Leone, wherever you are, Cameroon, wherever you are, what is the unit cost? That is the number one thing you need to master. What is the cost of a unit in your country? Okay? After knowing the cost of a unit, how much a unit cost? Okay? Now, I have come up with, once you know the unit cost, then, and you know how to calculate the kilowatt hour of the gadgets you use in your house, the formula which I have given you, then you can know how much you can pay every month. And if they steal you, you can go and report them or show the report that this is the unit I used, this is the figures which I'm reading on my measuring meter or my billing meter, and you're giving me a bill which is not the same with the readings on my meter. There are few people who come up with this and they take concern to read their electrical bill meters. But some people, they leave it for the companies. But if you're wise enough, if you're an electrician, you can understand that these guys are no longer reading the meters, that they are just giving me their estimated bills. But once you calculate it, you know the figure. It depends on which country you are. Know the unit, the cost of a unit. Now, for example, the cost of a unit in Uganda is 1,000 shillings. I don't know in US, I don't know. In African countries, I don't know. I only know the one in Uganda. Okay? Now, I've come up with a question which we are going to just try and we solve. Suppose I've called it an electrical bill, how they calculate us. Suppose your house uses a 6,000 kilowatt hour. Uses 6,000 kilowatt hour. This kilowatt hour are on the meter, on the measuring meter. The meter which is pressed outside of not outside of your home. Okay? The one they come and they read every month and they will be billing you. It is having 600 kilowatt hour. Okay? Electricity cost is, I have put it in dollars because dollar is a wide exchange rate in the world. Okay? I have used a 0.15 per kilowatt hour. Each kilowatt hour is $0.15. If in Uganda our per unit cost is 1,000, if you change this into Ugandan shilling, let's say if $1 is, let me talk about Uganda, wherever country you are, try to use this. You know the unit of the cost of electricity. Each unit, for us, each unit costs 1,000. Let's say it costs 1,000. And each $1 costs, let's say $1 costs 3,500 shillings, Ugandan money. Okay? I'm giving you a way how you can calculate your, even though you're not a billing engineer, you can go on your meter and you know the money you are supposed to pay. Sometimes these companies can make mistakes, errors. They can bill you the units you have not used. You must be conscious. Know the things. If you're an electrician, talk to the neighbors. Your neighbors, if they can give you some small income, you can calculate for them their billing and they will expect that amount to come at the end of the month. And once you expect to be paying, let's say 100, and they send you 500,000, you can go back and show them the picture. Get a picture of your meter reading. Go and show them that this is the unit which I've used. But this is the amount, but I have seen this kind of amount. Okay? Don't leave the work to them. It is your use. You're the one using this power. Once they are used, they can even calculate you and they give you a bill of 3 people. Yet you are one person. If you're not conscious, take care. Now, $1 is 3,500. Now, if I have used 0.15, just get, if it is 0.15, multiply it by 3 times 3,500, that is each dollar. You will get the amount. Okay, now if it is 3,500 times 0.15, it is going to give me 525 shillings. This is Ugandan money, meaning I'm using a 0.15 per unit. If you change it in Ugandan money, that is 525 shillings. This is dollar. Now to change it into your money, the country money, use this formula. Now let us jump into the formula. How these guys give us the bill. Once you know the amount of per kilowatt hour, the bill they will send you, they will get this 6,000 kilowatts times per kilowatt, the amount. This is in dollars. If you are in America, please try to check this. If your unit per electricity per kilowatt hour, if you know the amount, they get the total amount on your meter. If your meter is counting 6,000 kilowatt hour, they get this 6,000 times the amount per unit per kilowatt hour, which is 0.15. I've used 0.15 in dollars. This is a dollar. Okay, 1 unit of electricity is $0.15. Now you have used 600 kilowatt hour units on your meter. What is the cost? This is the cost. We calculate slowly. I don't want us to rush. I want us to be at the same pace. 600 times 0.15. You get $90. There you're going to pay $90. Now, if you are in any country which is not using dollar, just multiply this. If $1, check, if you $1 in your country, either African countries or anywhere, check what is the rate of $1. As I've told you, in Uganda, $1, let's say it is 3,500 Ugandan shillings. Now, multiply this $90 times the Ugandan shillings. $1 of Ugandan shilling. We get, that is the amount in Uganda. 90 times $1, which is 3,500. It will give us 300. This is the amount in Ugandan shilling, UG shillings. Now it depends on which country you are. Use this formula. How much dollar do you have? Do you make in your money? Naira, either any country, okay? Then multiply this dollar times this. You will know the amount you will get. Okay? And this is the in Ugandan shilling. Now, if you know this, this is how these guys send us the bills. If you know how to calculate your meter, record each month what you have used. Either you have used 600 on your meter, it is calculated in 600 kilowatt hour. Okay? Now, record this amount. If you want to get these electrical companies, record these amounts. Then, next month, this is the 1 month, okay? Now, next month, month 2, or next month, you will find that these units have increased, or they have increased like 610 kilowatt hour. At the end of another month, we shall have 610, meaning you have used only 10 kilowatts. Then you get this 10 kilowatts times the unit per unit. Per unit, we said if I'm in Uganda, each unit is 1,000. You multiply it by per unit. That is, they will send you a bill of 10,000 Ugandan shilling. This is Ugandan shilling. This is in Ugandan shillings. Okay? If you're not conscious to capture the things, to record these things, you know, every month they send you a bill. Compare this bill, the number in kilowatt. Go on your meter, check. You have eyes. Check if they read the same thing. Record also, if the end of the month ends, go back and check the meter and record the units in kilowatts. Multiply, or you know how the units which have moved. The last unit were 600. Now the new unit is 610. Multiply 610 minus the last unit, the last records. They will give you the unit which you have used. And you multiply this unit times the cost per unit, not the unit in your country. Don't be in the country when you don't know how much a unit costs of electricity. You will be lost. In fact, you are in the wrong country if you don't know a unit of per cost. And after getting the unit, I've given you an example. In Uganda, the unit is 1,000. One unit is 1,000. Okay? Now, 1,000 times the 10 units, 10 kilowatt hour which you have used, it is 10,000. Then at the end of the month, just pay 10,000. If you're not conscious on this, they will give you a bill of 100, or they can even give you a bill of 100,000 Ugandan shillings. Because you're not conscious, you don't know electrical energy. And you will see, I'm only using my TV, but the bill is coming too much. Why? Because you don't know. You have no records. Every month, electrical companies, each in every country, they must give you a bill which shows how much electricity you're using. There is no country which doesn't have this in the world. If you don't receive and you have their premise, you are using their electricity, you have a meter, please go and demand for your receipts. These receipts can help you to avoid this. You're using 10,000 Ugandan shilling, or you're using a $90 US shilling, and they are sending you $200. If you didn't know how to calculate, just a simple thing, record. If you want to do this, if you want some knowledge more about if you in a country you are, you can send me a comment in the comment section, then we can talk about it, and give me the cost per unit in your country of electricity. Then try to follow up. Just make it like 2 to 3 months. You will see the difference. You will see the difference. I am there for you, and we shall contact and we see how we solve these problems. This is just a problem, but not a problem. It is just your consciousness is because you don't care about electricity, and you'll end up paying a lot of money because you don't know. But once you know electrical energy, good to go to follow up your electricity, your water bills, the same thing. Okay? Okay, now after seeing how these guys do or give us electrical bills, I'll know from the beginning you have understood a lot of electrical energy, and we shall see how we can handle these electrical bills. Thank you for watching. See you in the next video. Click and subscribe to the channel for more engineering tutorials. Thank you for watching. See you in the next video.